This is the presentation for Topic 2, Economics of Maintenance, and it's for the subject Building Life Cycle Maintenance. Again, this presentation is to assist the study guide for the subject, and it's not really to be considered a replacement. Hoping that from this subject that you'll get an appreciation of the economics of maintenance and the type of techniques and economic appraisal, cost and use studies, also considering the impact of maintenance provision funds, and the significance of life cycle and cost, and the time data too, the value of the time data, and as well as the importance and accuracy of recording and reporting property operating costs. Operating costs in this case, we're mainly talking about maintenance. Again, as I've done in the previous topics, a couple of definitions. The first one here, maintenance costs. Costs of any actions carried out to retain an item or restore it to an acceptable condition, but excluding any improvements other than those necessitated by inability to replace obsolete materials or components. Try and keep that in your mind as we move through the topic. Now, if we consider the economics of the whole life of the building, I like this iceberg diagram here, which shows the obvious costs of the building, which is the capital costs and the site purchase costs that you can see above the water. Below the water are the costs that are incurred over the whole life of the building once it's being occupied and maintained. So you can see occupancy costs, maintenance costs, operating costs, and so forth. So as you can see, those items below the water, those costs during the life of the building, they're really important cost in use, and so cost in use studies are very important. And even more important now if you consider all those costs come into those type of contracts, such as public-private partnerships and joint venture projects, and all these projects which are now being introduced into Australia to build prisons, hospitals, stadiums, bridges, and so forth. The other thing that these items below the waterline here, showing in the economic appraisal, it's very interesting to note that the cost per annum of maintenance costs there is generally between 1.1 and 1.7% of the replacement value of the building. So again, this is a great diagram to sort of keep in your mind visually, understand the whole importance of life cycle costing, costs in use. So now if we consider that same life cycle cost and put it into a percentage of cost investment into a building over the life of the building, you can see that the initial capital cost, again on the left hand side, if you follow that graph through, the amount of investment in the building after it's been built, there's a considerable amount of costs that get attributed towards the maintaining and operating the building. And those costs in maintaining the building, you can see it grows in proportion of the percentage of the actual maintenance and energy costs. So the life cycling cost there is the collection of both, and as you can see there, as the building gets older, the life cycling costs increases more and more. So the life cycling really, if you consider overall now with greenhouse ratings and reduced emissions, there needs to be greater emphasis on sustainability and further reduce operational costs. The clients really need to establish a best value for money to solutions and to try and lower those life cycle costs and have the impact of those costs reduce. And that's not just as we discussed earlier in topic 1. There's also other considerations there rather than reducing costs. It's also to try to minimise the amount of outages and the interruption of business service and business continuity. To further emphasise the impact of the total life costs, a good example is often used with hospitals, where the operation phase, when it's fully costed out for a hospital typically has operating costs over 2.4 to 2.5 years, which is equal to the total acquisition and construction phase of the buildings. So that clearly demonstrates how important understanding the costs in use and those life cycle costs are when it comes to establishing a new building. So if we consider a very simple case study here, very simple numbers to demonstrate, we can look at a renovation of a building and a new construction of a building. And if we place that side by side and consider the costs associated with both the construction and the refurbishment and the operational maintenance, we can see here from the new construction versus the renovation alternative, we can start considering then options on investment initially and investment over time. And in this particular example, a very simple one I might add, the renovation alternative might clearly suit what the client needs, and so a decision can be made. So when we're considering the cost and use study and how to look ahead for what those life cycle factors might be that we need to be aware of over the life of a particular type of building, or as we looked at it in the previous simple case study, there's a number of things that'll determine the life. In this simple life cycle cost, life cycle analysis diagram, I've put in environmental, financial and social. And so those things you need to consider then clearly the economic life, which is really the occupation of the building and how long it can actually achieve some type of return on investment. The functional life, where the building ceases to function in its same purpose for what it was originally built. So some things will go beyond maintenance, beyond the ability to provide the service that it was set out to, and tenants may leave the building. There'll be technological obsolescence, and this is really where components are no longer superior, no longer able to support the function of the facility or the building. That could be a number of different things. It could be different types of pumping for water, or different types of fire safety protection, those type of things. Quite often lifts may suffer technological obsolescence only because newer and better buildings in a same neighbouring district are much faster, and so a lift eventually becomes technically obsolete. You can't get parts for it, that type of thing. There's also things such as social and legal obsolescence, where legislation quite often will dictate a replacement of things, and that'll appear in things like changes in fire codes or asbestos codes. When we're considering the life cycle costing and identifying the components of life cycle, to compile cost and use study and costing data, we really need to ensure that all of the building is accounted for in a life cycle study. But how do you administer and manage this? This simple hierarchy here shows really all the types of elements that you might need to consider. But having said that, every building will have a different group of these type of components. So it's really important that we have a uniform way to collect and manage the data of the building. And as I've said previously, that uniform code is quite often in Australia based on the NPWC, or National Public Works Council elemental format system, which is widely used. This NPWC system is often used in the construction and delivery for estimation and tendering, cost control, and in most cases also timing and programming. So by using it also then in the life cycle costing, you can bring those same elemental codings back into the estimating of the building, and that's particularly useful then for contracts that involve build, own, operate, transfer or partnering. So by having the elemental coding system up, we're up and running. We're really a part of the way there, but we still need to record the life cycle performance data in a logical format. In most cases now, it can be computer generated, even if it's by a simple Excel spreadsheet or Microsoft Access. Having said that, there's other programs such as BuildSoft and Costex that can actually assist in doing this as well. It's very useful if there is a cost plan already for the building, and so you can already establish a recording lifecycle performance database on the original cost plan. So the things that we really need to consider are the cost factors, the building elements, activities that are going to be happening throughout the duration of the life of the building, such as cleaning, energy, maintenance, and so forth. Any specific functional spaces that will have different life cycling components, such as offices, foyers, toilets, any operational areas that are unique to that particular type of building or that particular type of business. Resources which are unusual, materials and types of products that the buildings is made up of. The building quality and standard, and obviously the building type. Now the actual estimation of life for each type of building product really does impact on the nature of the cost data and the reliability of the cost data that we're going to use when we establish a life cycle for a building. The bank of cost data will have to be unique in most cases to the building's application and the building's environment. So whether, for example, whether the building's a coastal environment or whether it's an urban environment, and not just that, whether the materials that and resources in the building, whether they actually reflect an adequate amount of design and construction for that particular environment as well. So there's a lot of information on these particular building elements that's really reliant on the manufacturer's information and technical specifications. I must say that the biggest difficulty in life cycling is often the difficult nature of correctly assessing the maintenance and running costs of each different type of materials. There really is a scarcity of reliable information, historical data, when it comes to predicting the lives of components, and so it's really fraught with danger. The best method that I usually find is, once those life cycling costs and that data is established, is if you still have a connection with the building, is to have a program that annually or every so many years, 3 years or a 5-year window, actually reviews the life cycle of that data. The more you're able to do that, you can establish a more accurate database for both your own building or other buildings that you may be looking at. I mean, even when we look at the lives of commonly used materials such as paint, there's often surprising variations, and that's influenced by a whole range of factors. It could be paint type, number of coats, the condition of the base, the extent of the preparation, the degree of exposure, and the atmospheric conditions. So, as I've said, there's a huge amount of factors that play a role in the accuracy and the reliability of life cycle and costing data. Once you're satisfied with life cycle and costing data in a particular application of a building, it's possible then to create a schedule similar to this one here, that you can confidently start adopting life expectancies for the different elements of the building. And these are particularly useful, as I said before, in public-private partnerships or in venture projects such as build, own, operate, transfer, that you need to base that information on some type of knowledge or estimate. Now, sometimes a life cycle assessment or a life cycle cost, we might be looking at for a comparison of an individual part of a building or a service within a building. And this is a life cycle costing for a domestic hot water system, showing a comparison of each of them, including the running costs and purchase costs over a 15-year period, which is the general life of a hot water system. So, as you can see here, the quantum hot water system shown on the bottom there, which is a heat pump. The heat pumps obviously end up being the most economic over a period of 15 years. So this is an example where you can start really using life cycle cost and use studies to make a well-informed decision about which type of product that you should be incorporating into the building. Again, this type of outcome is very useful if you're putting it into a facility which maybe has 200 or 300 hot water systems, and again, it means that the reliability, the amount of outages, the amount of times they have to be replaced can be minimised over that 15 years, as well as knowing in advance giving some indication of where the money is likely to be spent throughout the duration of the hot water system installation. Okay, we've come to the time now where we can sit back and review the economics of maintenance. You can read the study guide, get a cup of tea, cup of coffee, and refer to the subject text and any course reading that comes with it. And also, it's probably a good time for you to start working through those workbook activities for this topic too. If you've got any questions, you can post it to the student forum, or you can email me directly.